Comparing and ordering numbers written in scientific notation. Let's take a look at these three examples here on the board. First, we have 1 and 43 hundredths times 10 to the 8th power. 1 and 25 hundredths times 10 to the 8th power. And last, 2 and 2 tenths times 10 to the 6th power. Now, in comparing these three numbers written in scientific notation, the first thing I'm going to do is I'm going to take a look at the exponent. Because I know the exponents tell me how many place value spots my decimal moves. So, the larger exponents are going to be my larger numbers. Here I have 10 to the 8th, and here I have 10 to the 8th. So when my exponents are the same, then next I'm going to go to my decimal number to figure out which one's larger. Well, I'm looking at my two decimal numbers here. I know that 1 and 43 hundredths is larger than 1 and 25 hundredths. So 1 and 43 hundredths times 10 to the 8th power is my largest number. 1 and 25 hundredths times 10 to the 8th power is going to be second. And the smallest number is going to be 2 and 2 tenths times 10 to the 6th power, because I know that this decimal is only going to move six decimal places. So here's the order from greatest to least. Why are exponents so important? Well, the first number on our last board was 1 and 43 hundredths times 10 to the 8th power. That's actually the distance that Jupiter is from the Earth. So if I were to write that number out, that 8 right there tells me I'm moving in a positive direction. And when I change my number back to its original form, all right, so I have 143 million is this first number. 143 million miles away from Earth. Let's go to Saturn. Saturn is 1 and 25 hundredths times 10 to the 8th power. So let's look to see what that becomes. The decimal is here. 1, 2, 3, 4, 5, 6, 7, 8. These are all the place value spots that my decimal moved. I'm going to put my commas in and look at my new number, 125 million. 143 million is larger than 125 million, so this number is larger than this number. And I can go to the last one, which is Pluto. 2 and 2 tenths times 10 to the 6th power. So I have a positive exponent. I know I'm moving to the right, but this time I'm only going to move 6 places to the right, whereas up here I moved 8 places to the right. 1, 2, 3, 4, 5, 6. And a comma and a comma. And I end up with 2,200,000, which is the smallest number out of the 3. So the exponents in these cases showed me the 6 I knew would be the smallest because it's the smallest exponent. The 8s I knew would be the larger ones, but 1 and 43 hundredths is larger than 1 and 25 hundredths. Okay, when you're comparing numbers written in scientific notation, you just have 2 simple steps. First, compare the exponent. The larger exponent is going to be the larger number. Your second step is if exponents are the same, then compare the decimals. So you're going to look at the decimal part of the number, and you're going to see which one number. Okay, at this point I want you to pause the video, and I want you to try these out on your own. Okay, we have 3 and 72 hundredths times 10 to the 3rd power. So I am going to compare that to 4 and 35 hundredths times 10 to the 7th power. I'm looking at my exponents. I have a 7 and a 3. 7 is larger than 3, so this I know is going to be my larger number just simply by looking at the exponent. And number 2, I have to use my exponents to tell me which one is the larger number. So now I have to go 4 and 6 tenths or 5 and 3 tenths. 5 and 3 tenths is larger than 4 and 6 tenths. So I know that this will be the larger number. This is going to be my smaller number. Number 3, I'm ordering from greatest to least. Again, I'm going to take a look at my exponents first. I have a 6, a 3, and another 6. Well, I automatically know that the two numbers that have a 6 as an exponent, those are going to be my two larger numbers. So next, I'm going to compare just those two numbers, decimals. So I'm going to take these two, and I'm just going to compare the decimal numbers, 2 and 3/10 and 3 and 6/10 to see which one's greater. 3 and 6/10 is greater. So this is the largest number, this is my second largest number, and this is the least. Number 4, I have 4 tenths, hundredths, thousandths, 10,000ths. 3 and 4 times 10 to the negative 5th, and 2 and 6 times 10 to the negative 3rd. First thing I'm going to do is try to figure out what this represents right here. Well, if I changed it into scientific notation, it would be 4 times 10 to the negative 1, 2, 3, 4, to the negative 4th. So now I'm going to look at my three numbers and I'm going to compare them. Which one had, I'm looking at the exponents and I'm looking to see which exponent is larger. When you're dealing with negative exponents, you want to see which one is closer to 0, closer to your positive numbers. I have negative 3, negative 5, and negative 4. Negative 3 is closer to 0, so this is going to be my larger number. Negative 4 is the next closest, and the exponent of negative 5 is going to be my smallest number, my least number. Right, last you have the question, why are exponents important in determining which numbers are greater? Exponents are important in determining which numbers are greater because the exponent tells you which direction that you're supposed to move in. If it's positive, you move to the right. If it's negative, you move to the left. The exponent also tells you how many decimal places that your decimal moves.